Hello everyone, in this video I'm going to teach you how to solve systems of linear equations in two variables by graphing. This will be easy if you know how to graph linear equations in two variables. Let's have an example. Solve the system x plus y is equal to 5, x minus y is equal to 1. Since we will solve the system by graphing, we will graph the two equations in a single Cartesian plane. Let's start with the first equation. To draw the graph of x plus y is equal to 5, we will identify two of its solutions. Assigning value for x, say when x is 1, y must be 4, so that 1 plus 4 is equal to 5. Another, when x is 4, y should be 1, so that 4 plus 1 is equal to 5. Therefore, the graph of x plus y is equal to 5 passes through the points 1, 4, and 4, 1. Let's have the second equation. Assigning value for x, let's say when x is 0, y should be negative 1, so that 0 minus negative 1 is equal to 1. Another, when x is 1, y should be 0, so that 1 minus 0 is equal to 1. Therefore, the graph of x minus y is equal to 1 passes through the points 0, negative 1, and 1, 0. And now we're ready to draw the graph of our equations. The first equation passes through the points 1, 4, and 4, 1. Plotting those points, 1, 4, 4, 1. Now all we have to do is to connect these 2 points to create the graph of x plus y is equal to 5. The second equation passes through the points 0, negative 1, and 1, 0. Plotting those, 0, negative 1, 1, 0, connecting those 2 points will give us the graph of x minus y is equal to 1. And as you can see, these two lines intersect at point 3, 2, which means that 3, 2 is part of the solution of x plus y is equal to 5. And it is also part of the solution of x minus y is equal to 1. Therefore, this 3, 2 is the solution to our system. Another example. Solve the system 2x minus y is equal to 3, 6x minus 3y is equal to 9. Let's identify two solutions for the first equation. Assigning value for x, when x is 0, y should be negative 3. Another, when x is 1, y should be negative 1, so that 2 times 1, which is 2, minus negative 1 is equivalent to 3. Therefore, the graph of our first equation passes through the points 0, negative 3, and 1, negative 1. For the second equation, assigning value for x, let's say when x is 2, y should be 1, so that 6 times 2, which is 12, minus 3 times 1, which is 3, 12 minus 3 is equivalent to 9. Another, when x is 3, y should be 3, so that 18 minus 9 is 9. Therefore, the graph of this equation passes through the points 2, 1, and 3, 3. Let us draw the graph of those two equations. The first equation passes through the points 0, negative 3, and 1, negative 1. Plotting those, 0, negative 3, 1, negative 1, connecting those 2 points will give us the graph of 2x minus y is equal to 3. The second equation, 6x minus 3y is equal to 9, passes through the points 2, 1, and 3, 3. Plotting those 2 points, 2, 1, 3, 3, then we will connect those 2 points to form the graph of 6x minus 3y is equal to 9. And as you can see, the two lines coincide, which means that all solutions to the first equation are also solutions to the second equation, or vice versa. Meaning to say, the system has infinitely many solutions. For our third example, solve the system 2x minus y is equal to 2, 2x minus y is equal to 3. Let's identify two solutions for our first equation. Assigning value for x, say when x is 0, y must be negative 2, so that the result is 2. Next, when x is 1, y should be 0, so that 2 times 1, which is 2, minus 0 is 2. Therefore, the graph of the first equation passes through the points 0, negative 2, and 1, 0. For the second equation, 2x minus y is equal to 3, assigning value for x, let's say when x is 0, y should be negative 3. Another value for x, let's say when x is 1, y should be negative 1, so that the answer is still 3 when we substitute the value for x and y in this equation. Therefore, the graph of the second equation passes through the points 0, negative 3, and 1, negative 1. Sketching the graph of those two equations, for the first equation, the graph passes through the points 0, negative 2, and 1, 0. Plotting those points 0, negative 2, and 1, 0, connecting these 2 points to form the graph of 2x minus y is equal to 2, while the graph of the second equation passes through the points 0, negative 3, and 1, negative 1, plotting those points 0, negative 3, 1, negative 1, connecting these 2 points will give us the graph of the equation 2x minus y is equal to 3. As can be seen on our graph, the two lines are parallel, which means they will never intersect, which means that there are no solution to the first equation, which also belongs to the second equation. And that only concludes that the system has no solution. So that's how we determine the solution of a system of linear equations in two variables by graphing. Thank you for watching. If you like this video, click on the thumbs up below. You may also watch our video regarding graphing linear equations using 2 points for review. And I would really appreciate if you will subscribe to my channel.